All right, derivative rules. Although I think really it should be like derivatives rule. So today we're going to look at the constant rule, the power rule, and the constant multiple rule. And then tomorrow, well, we'll do these, and then the next is this, and maybe this, and then this is whatever. It's somewhere down there. First up, the constant rule. So if f of x equals c, right? So you got a constant, right? Like y equals 5, right? That'd be a constant. Then f prime of x is equal to, so what's the slope of a, so like if y was equal to 5 or something, what's the slope of that line? All right, hang on. Y equals c, right? Let's just do this. Y equals c. Oh, come on. Not going to give me a, let's try y equals a. Why no slider thing? And why did this, one of these says delete all. Delete all. Y equals c. All right, fine. Y equals 5. What's the slope of that line? Equals 5. What's the slope of that line? 0, right? So a constant, right, y equals c, has a slope of 0, right? So what's f prime of x? 0. Or in the differential d by dx of c is equal to 0, right? Again, it's just alternate notation, right? Proof. So f prime of x, right? So the first principle is it's the limit as h approaches 0 of f of x plus h minus f of x over h. So what's f of x plus h for this? What's function notation say? Okay, so if you put an x plus h in there, what are you going to get? So f of x plus h is, really f of anything is c, right? Okay, whatever I put in here, what's the answer? There's no x here, right? So f of x plus h is c. What's f of x? C. Okay, so what is that? So that's the limit as h approaches 0 of, what's c minus c? Let's go with 0. Okay, so we got 0 over h. What's the limit as h approaches 0 of 0 over h? 0. Okay, so that's the proof, right, of the, what is it? The constant rule. Which just says that the slope of a horizontal line is 0, right? I mean, we knew this back in 10C. The power rule. If f of x equals x, then what's f prime of x? So if you've got the line y equals x, what's its slope? 1. If f of x is x squared, then use first principles. Okay, so first principles, that's f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h, which is the limit as h approaches 0. Okay, so now our function is square the thing, right? Square the input, and the input is now x plus h. So it's x plus h, quantity squared minus x squared over h, which is the limit as h approaches 0 of, okay, so what do we got? X squared plus 2xh plus h squared, that's this guy, right? Minus x squared, that's this guy, right? Minus the f of x, over h. Okay, so what do we do? Well, the x squared and the negative x squared, right, add up to 0. You can factor an h out. Limit as h approaches 0 of h times 2x plus h over h. Okay, so those guys, right? And now we can get rid of the limit as h approaches 0 by doing what? Putting in h as 0. Right? It's kind of some of the notation you've got to watch out for. You might see little circly stuff on the written response where your notation is, maybe you dropped this too soon or something. So what do we got? 2x plus 0, which is 2x. Okay, so if f of x is x squared, then f prime of x here is equal to, because the whole thing just carried through, right? So it's really equal to what's written here at the beginning. Let's throw that in there. If f of x is equal to x cubed, then use first principles, the definition of a derivative, right, to determine f prime of x. Okay, so it's the limit as h approaches 0. All right, did you guys, in 30-1, you did the binomial theorem, right?
Yeah.
Okay, so we can expand x plus h cubed. So what is it? It's 3 choose 0 x cubed, which is like 1x cubed, right? So 1x cubed plus 3 choose 1, which is 3, so plus 3, and then we drop the power of the x, right? X squared, and we increase the power of the h. Plus 3 choose 2, which is also 3, and we drop the x, but we increase the h. Plus 3 choose 3, which is 1, and then we just drop, the x is now gone, right? Cubed, squared, 1, 0, so h cubed, right? So that's the expansion of that, minus x cubed over h. Okay, so what happens up here? We get the x cubed plus minus x cubed, right? So we just kind of, all right, so these guys are gone, right? Equals the limit as h approaches 0. So what's left? Everything that's left has an h in there, right? But the lowest h is an h to the 1, so we can factor that up, right? And we know why we're doing that, so we can just get rid of it on the bottom. Okay, so let's do that. Let's factor out the h. H times, okay, what do we got? 3x squared plus 3xh plus h squared over h. Okay, so h's are gone. You can write in little ones there if you like. Equals, now at this point, what? We can drop the limit as h approaches 0 and do what? Put h as 0. Okay, it's allowed now because we won't be dividing by 0, right? That's gone. So we've got 3x squared plus 3x times 0 plus 0 squared, which is equal to what? 3x squared, right? Okay, so are we seeing a pattern here? So use your results to complete the following statements. Okay, so we did f of x equals x and f prime of x is 1. If it were x squared, then f prime of x is equal to 2x. If it were x cubed, then f prime of x is equal to 3x squared. What if we had x to the 4th? 4x cubed. What if we had x to the 5th? 5x to the 4th. What if we had x to the power of n? And x to the n minus 1. So in general, if f of x is x to the n, then f prime of x is, we already wrote it, n times x to the n minus 1, or d by dx of x to the n is same thing, right? It's just an alternate notation, right? F prime of x, d by dx of x to the n is n times x to the n minus 1. Now, we could actually prove that. So I'm going to just do a general proof here. We'll just quickly sketch out a general proof. You don't need to write this down if you don't want to. There's no room there for you to write it down. But if you want to pull out a piece of paper and write it down, or just it'll be up here, right? It'll be posted, and it's not something you're responsible for. But I think it's kind of neat to show, hey, let's just do this in a proof, right? So proof. So let's say we're doing d by dx of x to the n, which is the limit as h approaches 0 of x plus h to the n minus x to the n over h. And I'll go across because I've got some room running out. So x plus h to the n, well, we can use the binomial theorem to expand that, right? So what's it going to be? N choose, what do we count up? Yeah, so it's n choose 0, x to the n, plus n choose 1, x to the n minus 1, h, plus n choose 2. You've seen that? Have you seen that notation? Bracket notation? Okay, because we do it in 30-2, so I assume we do it in 30-1. X to the n minus 2, h squared, plus dot dot dot, n choose n, h to the n, minus x to the n, right? That's this guy, right? So this is the expansion of this, all over h. Okay, now n choose 0 is just 1, right? So this takes out, just like the x cubed took out the x cubed, right? And what are we left with? Well, all of these guys have an h, right? At least one h, and increasing powers of h. So then, we're just sort of generalizing. So it's going to be h times, okay, n choose 1, x to the n minus 1, plus n choose 2, x to the n minus 2. And we're just going to drop the power on this, right, because we factored out an h. So this will be an h. Dot, 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 n choose n, h to the n minus 1 over h equals the limit as h approaches 0. Now I know where you get your bad habits from. Okay, now we can drop the limit, right? Put in an h at 0, and what happens, right? Well, all of these guys are gone. And what are we left with? N choose 1, x to the n minus 1. What's n choose 1? N, right? So it's n, x to the n minus 1. Right? Nice. General proof of the power rule. Okay. Examples. So if y equals 7, so just using different notation, right? So y equals 7, then what's y prime? 0, right? The constant, okay, uses the constant rule. If g of t is t to the 10th, then g prime of t is? Yeah, 10t to the 9th. D by dx of x is? 1. D by du of root u. Let's go look at this one. I don't know if you have room to fill this in or not, and it's not important, but d by du of root u is equal to the limit. It's not important you write this out, okay? But you might want to, and I don't know if you can squeeze it in or if you want to, but so it's the limit of what? Well, it's going to be root u plus h minus root u over h, right? Because the function definition is the square root of, right, the input. Okay, so what are we going to do with that, right? We're going to multiply it by root u plus h plus root u over root u plus h plus root u. So we're going to rationalize the numerator, right, hoping to get an h out of there, which will cancel with the h down there. So equals the limit as h approaches 0 of, okay, what do we got? So it's going to be u plus h minus u, right, difference of squares, right? So it's going to be the square of this, which is u plus h, minus the square of this, minus u, over h times the root of u plus h plus root u. bracket. So u minus u, 0. H's cancel, right? We now drop the limit and actually put h as 0 in. So what do we get? So it's 1 over root u plus 0 plus root u, which is 1 over what? 2 root u. Okay, now let's think about what's another way to express root u. Yeah, so root u is u to the power of 1/2. Now what does the power rule kind of say to do? So d by du, so let's do this. So up here we'll write u to the 1/2. So the power rule says take the power, stick it in front. So 1/2, and do what to the power? So it's n, x to the n minus 1, right? Now, up to now we've worked with n as being an integer, and now n is, a rational. So it's 1/2 u to the 1/2 minus 1. So what's a half minus 1? Negative 1/2. What does a power of negative 1/2 say to do? So the negative says go down here, right? So it's 2u to the what? To the power of positive 1/2, which is equal to 1 over 2 root u. So the power rule works even with rational numbers, right? So the power rule works even if you're dealing with a rational number. You can still do the power rule. That's kind of neat, right? What's next? So d sub x, you're not going to see that a lot, but d sub x of 1 over x to the 4th. So what should we do with that?
X to the power of -4.
Yeah, let's write it as x to the power of -4, right? Because we know how to deal with the power rule, which says if you have something x to the n, so does it work with negatives? Well, what would you do?
4x to the power of -5.
Right. Okay, so -4. So move the number out front, right? So it's n times x to the n minus 1, and subtract 1 from this number. So -4 minus 1 is -5, which you could then write as -4 over x to the 5th. Yep.
Where did the -5 come from?
Power rule is x to the n. So power rule says that d by dx of x to the n is equal to n times x to the n minus 1. So this is -4, right? So this becomes -4x to the -4 minus 1, which is -5. Okay, so you're dropping your power by 1, right? That's how the half ended up as a -1/2 and ended up underneath, right, as 1 over 2 root u, which we knew it had to be because we actually worked it out from first principles. We got 1 over 2 root u. Okay, and generally, if you start with the root u here, you want to end up with the root u in your answer, right? And yeah, we're going to leave it in the denominator. Okay, it's all the rationalizing stuff. All right, so we good? It's all right, it's all right. The constant multiple rule. If g of x is equal to c times f of x, then g prime of x is equal to c times f prime of x. Or d by dx of c times f of x is equal to c times d, not very good, d, d by dx of f of x. Okay, again, just different notations, right? Same idea, different notations. The proof. Well, g prime of x is equal to the limit as h approaches 0 of g of x plus h minus g of x. But what is g of x? Excuse me. So limit as h approaches 0. So g of x plus h is equal to c times f of x plus h, right? You put an x plus h in here, then you're going to put an x plus h in there. So it's c times f of x plus h minus c times f of x over h, right? Which is the limit as h approaches 0. So we can pull the c out, right, as a common factor. So c times f of x plus h minus f of x over h. And if you have a constant inside a limit, then we have the limit property, which says that you can pull the constant out front, right? So that's equal to c times the limit as h approaches 0 of f of x plus h minus f of x over h. And what is the limit? Well, what's another way of saying this is just f prime of x, right? So this is equal to c times f prime of x. So there's the proof, right? Just using that property of limits, that if there's a constant within your limit, then you know that you can just move that out front, right? And write as the constant times the limit of. And this expression is just f prime of x. Differentiate. Okay, so if y is negative 6x to the fourth, then we say, okay, so y prime is equal to c, right? That's the constant, times f prime of x. Okay, so what's f prime of for x to the fourth?
4x to the third.
4x cubed, right? Yeah. Which is equal to negative 24x cubed, right? Y equals, that's it, right? Okay. We're done. Most of the time, I would generally just go straight to negative 24x cubed, but we want to split it out to say, look, it's the constant times the derivative of. So again, we're going to do the same thing here. So y prime is equal to the constant, which is 10, times the derivative of x, which is 1. And 10 times 1 is 10. Okay, a little bit more work here. So when we see a root, we should write that as a power, right? So you see a root, right? The square root of x. Well, okay, so that's x to the 1/2. If it was the cube root of x squared, right, it'd be x to the 2/3. Okay, so f prime of x, it's going to, well, actually, probably we need to go one more step here, right? Okay, so we want to write it as a constant times a power of x. We want the power of x to be in the numerator, right? So we got x to the 1/2, we got x to the 2. So what is it? X to the power of what? So it's going to be 1/2 minus 2, right? Okay, maybe write that. We got room. So it's 3 times x to the, so what's 1/2 minus 2? Negative 3/2, right? So we've got 3x to the negative 3/2. Okay, now we're ready to do the derivative, right? Because it's written in the form of x to the n. Okay, now the constant, well, okay, what do we do? So it's f prime of x is equal to the constant times the derivative of this, which is?
-3 halves x to the power of -5 halves.
Exactly. Okay, so the power, right, it's n. What's n? -3 halves. X to the n minus 1. Right? So the power goes down, -3 halves. X, we take -3 halves minus 1, which is -3 halves minus 2 halves, which is -5 halves, right? You'll get good at this. Okay, so what have we got? So 3 times -3 halves, -9 halves. What are we going to do with the x to the -5 halves? Okay, so it's going to be -9 over 2 x to the 5 halves, or -9 over 2 square root x to the 5th. Right. So it's just the definition of x to the 5 halves, right? It's the root. Remember, the bottom number, the denominator is what root, and the top number is what power. Okay, so it's -9 over 2 root x to the 5th. Okay, and again, right, we start with the root, we end with the root. Okay, and that's what you should be seeing in the back of the book, right? Okay, everybody good with that? So you're starting with the root, convert the root to a fractional exponent, right? Get it so that your expression is in the numerator, right? You don't want it down here, right? So we need the power of x up here. Got a constant, fine, we just take the constant times the derivative of this, okay, derivative, power rule, right? So it's n x to the n minus 1. Negative exponent becomes positive exponent. If you want to just move this down here and write it as the root, you know, going from here to here, that's fine. Did I have notes? Somewhere I had notes. I am. I was going to do a little bit of room here. I just want to throw in a couple more, just in notation. So if f of x is 1 over x squared, then f prime of x is equal to d by dx of x to the -2. And this is just showing the differentiation operator, d by dx, right? So you can take and then make this x to the -2, you know, which is -2 x to the -2 minus 1. Okay. You don't have to write that. You could actually just go straight to the -2 x to the -3, and then write that as -2 over x cubed. Okay, and again, it's just showing a slightly different notation, right? As f prime of x is d by dx of x to the -2, and then use power law, and don't leave a negative exponent in the end, move that down there. Okay, here, let's squeeze one more in. If y is equal to the cube root of x squared, then dy by dx is equal to d by dx of the cube root of x squared. Okay, so dy by dx is just another, you know, it's another word for y prime, right? But we're saying it as dy by dx. Is d by dx of this, which is equal to, well, d by dx of x, so what's the power? 2/3 is equal to, and now we're actually going to do the derivative, so it's going to be 2/3 x to the what? So it's 2/3 minus 1 which is 2/3 minus 3/3, which is negative 1/3. Okay, so we don't leave it like that, right? It becomes 2/3 times the cube root of x. Right? So now we're moving it down as x to the 1/3, but then we're just writing it as the root. So it's 2/3 cube root x. Okay, and if you want, then there's a little step in here. It's 2/3 x to the positive 1/3, which then translates to. Okay, good. Just another couple of examples, right? Example 3. Flipping backwards. Determine the equation of the line tangent to the curve f of x equals negative 2x cubed at x equals 4. Express your answer in the form ax plus by plus c equals 0, where a, b, and c are integers and a is greater than 0, right? Positive x value, just the usual. All right, so remember how we used to do this, right? Negative 2x plus h, blah, blah, blah. Well, now we know what? Well, we want to find the derivative, right? Which is the slope. So we know that the slope of the tangent line is equal to f prime of x, which is equal to, all right, so what's f prime of x? Okay, so we've got the constant, right, negative 2, times the derivative of x cubed, which is, I want the derivative of x cubed, which is 3x squared. Remember how when we were doing the slider thing, how the derivative was of a degree 1 less than, right? We had a quadratic, and what did the tangent line look like? It was linear. We had a cubic, and what did the tangent line look like? Well, because it did this, we had to go up and then down, and that was quadratic, right? Now, power rule makes even more sense, right? You say, oh, yeah, because your derivative curve is going to be 1 less. Think of number of turning points you could have in a 4th degree, right? That you could generate a cubic out of that. And it doesn't necessarily have to be. You could just take x to the 4th, right, which is just kind of a flattening out. Looks a lot like x squared, right? So you're going to get a slight flattening out. You will actually get x cubed, right? Derivative of x to the 4th would be 4x cubed. Right? So you still get a cubic, but it's not going to have any turning point. It will have that point of inflection. But anyway, we're actually doing this, right? Okay, so f prime of x is equal to negative 6x squared. But what do we want? We want f prime of 4, right? We want to know. But now it's very easy to generate the general form for the tangent, right? General form, because we don't have to do the first principles, f of x plus h minus, limit as h approaches 0 of f of x plus h minus f of x over h. We got rules. So what's f prime of 4? Well, negative 6 times 4 squared, which is negative 96, right? So 4 squared is 16, and 6 times 10 is 60, and 6 times 6 is 36, and 16 36 is 96. Because you don't have a calculator. All right, now, we need another piece of information, right? We need to know the point, right? Because to find the equation of a line, you need the slope. We have the slope, we need a point. And the point is, well, f of 4. Which is negative 2 times 4 cubed. What's 4 cubed? 64, right? I cheat. I do 2 to the 6 instead. But whatever. So, negative 2 times 64 is negative 128. All right, so we have a point. Let's make a point of that. We have a point at 4, negative 128. We have a slope of negative 96. And we need the equation of a line. So use your favorite form for generating this, right? I'm a point slope kind of guy. I like the point slope form for the formula, right? So it's going to be y plus 128 is negative 96, x what?
Negative 284.
I don't see that number up there. X minus what?
It should be 4.
4.
Oh, yeah, but when,
Oh, you're going with
yeah.
like this times. Yeah, we got to get there. Okay, so y plus 128 is negative 96 plus,
I think it's negative 284.
well, I think it's positive.
Oh, yeah, 284. I think.
Okay. Well, so what's 4 times 100 is 400, but we're 4 shy, and 4 fours is 16, so 384 sounds good to me. And there's an x in here, right? Don't forget the x. Okay, so we need to have a positive x, so we're going to move that over to the left, right? Get 96x plus y minus, so we got 384 minus 128. So 284 minus 28, I can't do that, but I can count up from 28. 38, 48, 58, 68, 78, 88, that's 60 minus 26, which is what, 54? So what is it, minus 2, what? 384 minus 128, I don't know, 7, 14, there's a 6, 5, 2. We did it! Equals 0. I can do arithmetic if I have to. So 96x plus y minus 256. Okay. Now, if I were curious and was at home and had Desmos, I might graph those, right, just for the heck of it. Okay, and then just kind of zoom around to see. It really does look like that, you know. It really is the slope. You know, the slope is 9. That's gonna, you know, look pretty straight up and down, right? Or you're going to have to zoom out a fair amount to get any angle on the line. A slope of 96 is like up 96 and over 1. So depending on the scale you're looking at it, it's almost vertical. So you sort of drag the scale out a bit. But okay. Example 4, determine the point or points on the curve y equals 4 over x where the tangent line is perpendicular to 8x minus 4y plus 1. Okay, so what are we going to start with? What are we going to start by doing? So let's find the slope of the tangent line of this, right? Okay, so what's the slope of the tangent line to this curve? Okay, so y is equal to 4x to the negative 1, right? So let's start there. So y prime is equal to, so we got the constant 4, and what's the derivative of x to the negative 1? So negative 1 times x to the power of negative 2, right? So negative 1 minus 1 is negative 2. Okay, so that's equal to negative 4x to the negative 2, which we're going to write as what? Negative 4 over x squared. Okay. So we have found the slope of the tangent line. Now we want that to be perpendicular to 8x minus 4y plus 1 equals 0. So what do we have to, what's the next step? So we're going to have to figure out the slope of the given line, right? And then, I mean, it's already said negative reciprocal, but I think we got to figure out what the slope is first, and then get the negative reciprocal of that. So we want the slope of 8x minus 4y plus 1 equals 0. So we've got 8x plus 4y minus 1 equals 0. So what's a good way to find the slope of that? Write it in y equals form, right? Yeah.
It's actually 8x minus 4y plus.
Short-term memory. Thanks for that. I mean, Is that right? 8x, yeah, okay, good. Okay, so what do we want to do with this? Put it into y equals, right? So what's it going to be? So 4y is equal to 8x plus 1. So y is equal to equals 2x plus 1/4, right? And I really don't care about the 1/4, but you know, for the sake of making it look nice. So the slope of the line is 2. So what's the perpendicular slope? Negative 1/2, right? Now comes the negative reciprocal, right? There's a little bit of work before we could, you know. So try not to leap too far forward in your thinking. And when you're writing stuff down, like on a test, especially written response, sometimes you might have to show a little bit more work. Some of you are making too big of a leap in one step. Remember, stupid people are marking your thing. That's me. And you know, if it's too big a leap, then my brain gets all confused. It's like, how did that happen? So, you know, you don't have to go overboard with detail, but you know, keep in mind the guy that's marking it. So he's a little bit slow. So you gotta, you know, go step by step, and life is a bit easier. All right. Because I even forgot. I don't even know what we're doing here, right? We've done a bunch of stuff, but what were we actually doing? Determine the points on the curve where the tangent line is perpendicular. Okay, so I want the tangent line, which is negative 4 over x squared, to be perpendicular, which means it has to be equal to negative 1/2, right? Okay. So can we solve that? Probably, right? What do we get? Negative x squared is equal to negative 8. So x squared is 8. So what is x? Well, it says point or points. Plus or minus, right? So when you square root both sides, plus or minus, okay? So plus or minus root 8, which is what? Yeah, plus or minus 2 root 2, okay? So is that it? Am I done? No, I found the x. We got to determine the points, right? So a point has an x and a y, and we've got the x, so we now need to get the y, right? So we need to put the x into here to get the y. Actually, put the x's. So when x is equal to 2 root 2, y is equal to 4 over 2 root 2, which is 2 over root 2, which rationalizes 2 root 2 over 2, which is root 2. Okay? So we've got 1 point is, 1 point is 2 root 2 comma root 2. Okay, that's 1 point. 1 point. And the other point, so when x is equal to negative 2 root 2, then y is equal to 4 over negative 2 root 2. Now, you can kind of cut to the chase. What is it? Negative root 2, right? I mean, we've already solved the same problem with the positive end of things, so I think we can just say negative root 2 here. And so we get the point 2 root 2, negative root 2.
Isn't it negative 2 root 2?
Negative 2 root 2, at least that's easily corrected with a small little dashed line thrown, or sorry, a dash. Thanks, that's good, right? Hate to have stopped recording and left it, but then I have to put a little box in and say, oops, sorry, this is actually negative. So they weren't on the ball enough to stop me from, you know, wait, stop, don't hit done. All right, I think we're done though, right?
Yeah.
Well, we're sort of done. Yeah. It's good enough. I could do another one, but really, what's the point, right? You could do it. Done.